My first guest really needs no introduction, but I will try anyway. Through the podcast, I get to have a lot of conversations with a lot of incredible people and learn about how they got their start in machine learning. And it probably wouldn't surprise you that many of the folks that I talk to got their start with my first guest's courses, his Stanford University courses, Coursera, and more recently, Deep Learning AI. In fact, I got my start in this space taking one of his courses, and I can't think of an individual who's helped me more, who's helped more people enter this space than our first guest, Andrew Ng. Andrew? Welcome to TWIMLcon.
So it's great to see all of you here.
It is great to have you here. So my first question is, I don't know if you saw it on the document that had your autograph, but I lost 4.85 points on homework assignments in your course. What was that all about?
Yeah, I'm sorry, Sam. I think you are perfect. It must have been a bug in the other grader. It's the only possible explanation.
Awesome, awesome. So you also launched your most important learning machine, Nova, back in February. How's fatherhood treating you?
Yes, so Nova's now 7 months old, but you know, there's actually a story about how we chose her name. We wanted her to have the initials, you know, neural networks taking off, so I wanted her initials to be NN, so Nova. But one layer deeper than that, you know, thinking, all right, have a new baby. I think every person on the planet is a unique person, is a unique human being. So people are, no one is a number. So we gave her the middle name Athena. So her full name is Nova Athena Ng. Thus the initials are NAN. That's a burden she had to carry with her for her whole life.
Nice, nice. So you are prolific. You are up to so many things. Can you give us an overview of what you're working on nowadays?
Yeah, the team's, the rise of AI, the rise of machine learning means there are a lot of pieces needed for it to reach its full potential. So right now, the three teams spending most time with them leading are Landing AI, which is helping companies jumpstart AI adoption, Deep Learning.ai, which is our educational arm, produces content. A lot of it is on Coursera. Also, our weekly newsletter called The Batch, which you can subscribe to get weekly news about machine learning. And then also AI Funds, which is a startup studio that builds AI-powered startups from scratch. The rise of machine learning creates a lot of new opportunities. So building these three teams which work together in an ecosystem, trying to build in the pieces that let us build an AI-powered future.
Awesome. And so let's dig into Landing AI a bit. I associate that with doing work in the manufacturing space. Give us an overview of the company and what it's up to. Is that the case?
So I think I saw with my own eyes how an injection of modern AI can make a company much more effective and valuable. I think, you know, building out Google Brain and then leading AI at Baidu, I saw, right, with my own eyes, a couple of great companies become modern AI companies, become much more effective and valuable along the way. But if you look at what we've done in the machine learning world, I think we've transformed the software internet sector. So many of the companies represented, you know, at this conference, and many companies in Silicon Valley and Beijing, even outside the top small handful, you know, kind of getting a lot of traction in AI. I think the next step for AI is for us to transform all of the other industries as well outside software internet. And so Landing AI works with many companies from manufacturing to agriculture to healthcare to others, and we can act as a partner's outsourced chief AI officer to help a partner build an AI function, train a team, develop IP, and our model is we help partners, we will cook for you, but also teach you how to cook so that after a couple of years you can in-source the function and be an AI-enabled business in your vertical, which we think can help a lot of people and help a lot of companies become more effective and more valuable. And frankly, our goal, there's more to life than financials, but I think our impact, we hope, actually has a material impact on the market cap of companies we work with.
Awesome. Can you give us an example of some of the types of problems that you're helping customers solve?
Let's see. One of our engagements has been with a large agriculture machinery company, and I think if you can help a company, reposition from being a traditional agriculture company to being an AI-enabled agriculture machinery company, then you can build smart agriculture machinery. We're going to have the same farmer, same farm, but with automation suggestions for how to control the machine better. You get more crop. Right, from the same farm, and so this is a direct impact on the farmer, as well as, not surprisingly, on the company building these types of things. I think, I was just in Latin America actually last week in Colombia, visiting companies in different industries as well, from logistics to manufacturing, and what I'm seeing is that there's very strong CEO level interest to help companies in all sorts of industry sectors become AI enabled. And it's not that if you're a manufacturing company, you want to become an AI company. It's that, let someone else do that. But I think in the future, an AI enabled manufacturing company can be much more effective and valuable than one that doesn't. Maybe one of the last disruptive ways of technology was the rise of the internet, and we saw that if you have a shopping mall plus a website, yes, everyone has to build a website, but that doesn't turn you into Amazon. Or if you're a taxi company and you build a website, you're not an internet company. Instead, Uber, Lyft, Grab, Didi are true internet companies. AI arguably is as disruptive as the internet. And so there will, and it changes the core of how different companies will compete. What are the things that help you build a defensible business? What are the things that generate value? Where do you play? Where do you not play? What is the new strategy? And I think companies able to figure that out will become, will survive and thrive. One of the myths we tell in Silicon Valley, which is not true, is that whenever there's a disruptive technology, it's always the startups that win. That's just not true. With the rise of the internet, some startups that did well include Google, Facebook, and Amazon, but some incumbents that did well include Microsoft and Apple, which were not internet companies, but became great internet companies. So with the rise of modern machine learning, and the exciting work that many of you in this community are doing to land these technologies, to bring them to fruition, I think this is the race is again on, where there are great opportunities for startups, but incumbents also have a lot of advantages, and if they play their cards right, they can become very valuable, very effective AI-enabled businesses in their verticals.
So what's involved in playing those cards right?
So one of the hardest things for companies to embrace AI is to scope the right set of projects. And so we spend a lot of time, I think we've actually become very good at working with companies to figure out what you should and should not use machine learning to do. I think some pieces of advice I give to companies: one, to start small. Maybe actually here's a story. When I was some companies try to do the biggest, most glamorous project as project number one, and that's usually a mistake. It leads to failure that then causes you to lose faith. Actually sets the company back because you need to regain the faith. One story: early days of Google Brain, people in Google were still certainly didn't know how to use deep learning, or even skeptical about it. So my first internal customer was the Google Speech team. Wasn't the most, it's not web search advertising, right? Speech recognition is a nice project, but it's not web search advertising. But by making Google Speech more accurate, it helped other teams excuse me. It helped other teams within Google gain faith in our ability to deliver results. It also taught the company how to use, deep learning. I remember when our first GPU server, it was just a server sitting under some guy's desk with a nest of wires. But that taught us important lessons about how to train models on GPUs. After the first successes, second internal customer was Google Maps, where we use OCR, photo OCR, to read house numbers to more accurately place houses on Google Maps to improve quality map data. It was only after those two successes that I then started a more serious conversation with the advertising team. So So one lesson from this is I think start small. It's more important that your first project can be something like speech recognition, back in the day, to help the company learn what it feels like and then to use that to build momentum. And then I think it's important to form cross-functional teams with machine learning experts and business application experts to brainstorm projects together. One tip I offer a lot of companies, kind of a pro tip, often the #1 project that the CEO gets excited about, that's actually not the project you should work on. So I recommend to companies to brainstorm at least half a dozen projects and spend a few weeks deeply evaluating, is it technically feasible, is it actually valuable, and do that before investing, few months worth of resources to do that. And I think, so as a quick answer, several months ago, published online an AI transformation playbook, which talks about a sequence of steps from scoping pilot projects to building a team, to providing training, to thinking through AI strategy, to even communications, including some of the pre-IPO companies you work with, value, make sure they're communicating their AI value thesis creation clearly, but that type of AI transformation playbook, which you can find online to help a company become AI-enabled.
Yeah, one of the things that I find fascinating in speaking to folks that are leading these efforts is the challenge of managing the portfolio of projects. They need to start small and kind of pick off the easy wins, but they also need to maintain that vision, the overall promise of AI and what it can lead to, so that they can continue to drive enthusiasm. Do you see that as well?
Yeah, I think it depends. That's an interesting point. I think there's enough excitement. Oh, thank you. I think depending on the company, I sometimes think it's important it's like Goldilocks principle for AI, right? To not be overly optimistic. So AGI is not around the corner, at least unless Elon Musk has a secret lab somewhere of technology. But also
Which he may.
But also not be too pessimistic, because there's a lot it can do. If you under-aim, then your competitors or someone else, you're missing out on opportunities. So I think it's important that not just engineers know how to do this, but that company management and executives also learn how to do this. Actually, we're running an event in Colombia. We run these events around the world called Pine AI. But I was running an event in Colombia, and I met this engineer who came up to me, and she said, "Hey, Andrew, I love your AI for Everyone course." And this is a very technical person, right? AI for Everyone was scoped for a non-technical audience. And she said, "Love your AI for Everyone course. Not for myself, but I'm getting tons of non-engineers to take it, and this is making them much easier for me to work with." And I find that in a company, if the management structure, the product managers, the executives, even the C-suite executives have a basic understanding of AI, then the machine learning team or the data science team is actually much better set up for success.
Awesome, awesome. And so when organizations do make that commitment and initial investment, spin up teams, how well do you think enterprises are doing in getting value out of the other end of their ML investments?
I think it's really hard. We've seen the large companies, the mature, relatively sophisticated technology companies are getting pretty good at building and deploying machine learning systems. But I think that a couple challenges. One, AI grew up in consumer internet companies, which just have a lot of data. Maybe if you have 100 million users or 1 billion users, you have a lot of data. In other industries, you often don't have that much data. So if you're a manufacturing plant doing visual inspection, using computer vision to tell if a smartphone is scratched or not, you don't have 1 million pictures of scratched smartphones because you just fortunately did not manufacture 1 million scratched smartphones along the way. So I think how do you get machine learning to work with small data instead of big data is an important technical challenge. And then it turns out some of the processes we use in big companies. I mean, so when I was deploying, deploying a large speech recognition system, right? Well, what happens? You deploy the model, and then the world gives you data that's different than what you had in your test set stored on your hard disk, right? So again, in the early days, the conversations would go like this. The machine learners would say, "Wow, look, I do so well on the test set, And then the business people will say, no, look, the customers are doing these crazy things. They're talking in the car, there's background noise. Your speech recognition engine doesn't work. And then the machine learning says, look, I did so well on the test set. What are you talking about? And I think the machine learning world, I think now more machine learning people realize our job is not to do well on the test set you have on the hard disk. The job is to build a product, move the product or the business forward. But if you look at how we used to solve these problems, what we used to do was if we ship a speech system and for whatever reason the performance degrades, then we would monitor it, alarm it, and then page a duty or whatever, and then someone like me would go, hey, you 20 engineers, there's a problem, please go and fix it. Now the large companies could do that. Every time there's a significant problem for a major product, we could find 20 engineers to then go and page a duty people and fix it. But for other applications where you just cannot afford to do that, we need better, more systematic ways to monitor, alarm, mitigate. So I think the whole machine learning world, including I think many of you are coming up with better. I guess in this community, ML ops seems to be a growing term to figure out the processes to manage that.
Okay. So many organizations, including many of the folks here, are in this transition point that I described earlier. They've launched successful proof of concepts. They've generated excitement within their organizations, and now they need to scale up so they can get more models out into production. What have you seen working in those organizations that are similarly situated, that are scaling up their ability to drive real value out of these models?
Yeah, I think that I know that this conference talks a lot about platforms, and I think platforms are important, but it helps with the technical aspects of scaling these up. I think what makes scaling up hard is even more the people business aspects of it. Although the technical aspects of it are really important too. Actually, after Sam and I were chatting like a couple of days ago, and after our conversation, it was very interesting. I went back and reread this 30-year-old paper by Fred Brooks titled "No Silver Bullet," and it made the point that even as we improve programming languages, basically, software engineering is still hard, right? Now, I'm really glad that I could code in Python and not, Fortran or assembly or something. I think we're all
happy about that.
But even though we now have Python and these fancy tools, TensorFlow, PyTorch, software engineering is still really hard. And that's because the tools we have did not remove the essential complexity, this is Fred Brooks' term, the essential complexity of software engineering, which is to think through clearly what you want to do, to write the specification, to then express it, and then to test it. And the hard part of software engineering is not, do you use a go-to statement, or do you use a fancy while loop or whatever? It is thinking through clearly what is the problem and what are the steps needed to solve it. Now, one of the beautiful things about modern machine learning is that it removes essential complexity from a task. As in, I don't know, 10 years ago, if you're building a computer vision system, it was really complicated. You would download these now maybe arguably obsolete algorithms, SIF, SURF, HOG, have these features, then you do something crazy about color normalization, right? You feed it through some software library, say OpenCV, find it doesn't work, you warp the image. Well, there's this crazy complicated set of steps.
And you did it all in Octave.
Oh yeah, yeah. Actually, OpenCV, which was C in C at the time, I think. But what deep learning allowed us to do is to say, forget all these steps. Let's get a lot of data, train a neural network on it, and so the workflow changed dramatically with the rise of deep learning, which is why we can do so many more things now. Now, I think just as I'm happy to use Python instead of Fortran, we've been seeing a lot of improvement in developer tools for building and deploying machine learning. Some of this removes accidental complexity, Fred Brooks' term, and I think we need more thought on how to remove the essential complexity of the work we still have, which is, and a lot of my work is meeting with a company, meeting with CEOs, leaders, brainstorming what are the things actually valuable to the business, thinking about where do you get data, and do they have data, and how do you organize the data, and then those things essential complexity things that are still difficult to relieve with today's tools. Which is not to say tooling is not important. Okay, Python is great, but I think the heart of what makes a machine learning problem difficult is still thinking through clearly what is the problem you want to solve and where to get the data, even though I'm grateful for the much better ways we have today for expressing the neural network architecture I want to train.
Yeah, you talking about that, what you referred to as accidental complexity versus kind of essential complexity. A very similar theme is the core mission and motivation behind Airbnb's platform team. They refer to it as their mission as being eliminating the incidental complexity of machine learning so that their engineers can focus on the unavoidable complexity, that essential complexity that you referred to. And that has kind of powered their development of a whole set of platforms and tools to allow them to move more quickly. And when we spoke about this a couple of days ago, you made an interesting point about one of the success factors being an organization's ability to iterate quickly. Are there particular things that you've seen organizations do that allow them to iterate very quickly and do more experiments, understand what's working, what's not, with a shorter time lag?
Yeah, so here's one example of a slightly unusual process that some of my teams use. We all use the agile, 2-week sprints. Some of my teams use a 1-day sprint. So the workflow is like this. We wake up in the morning and look at the experiment results that we have run overnight, and then we do error analysis, gap analysis, error analysis to figure out, what are the shortcomings of the algorithm. So we do that in the morning. And then based on that, we brainstorm what to do collect more data, change the network architecture, add regularization, whatever, brainstorm a bunch of stuff. And then different tasks, different team members take on different tasks. I get more data, you try that, regularization, hyperparameter, you try that, data augmentation, whatever. We write code in the afternoon or write code late morning through afternoon, evening. And then we run the next experiment overnight. And then the next morning, we wake up and look at the experiments from last night and then iterate the next day. Error analysis, plan out what to do, run code overnight. So this workflow isn't for everyone. It tends to work best for when the machine learning job takes, like 4 or 5 hours to train, because that workflow fits in well with this type of cadence where you code during the day and run experiments overnight. But I found that if you could in agile development, we were used to this idea that you should replan every 2 weeks or whatever is your sprint cycle. But in machine learning, it turns out a lot of the workflow of building a machine learning system, it feels more like debugging than development. That's a key insight that some of my teams had. And with that, and so this daily sprint cycle was found to be a good practice for quickly driving down errors of certain types of workloads. I think a lot of us are still making up, are still inventing these new processes. Think of how long did it take our community? We went through a lot of versions of version control, right? From emailing each other code in email to Git, right? To I guess CVS subversion Git, right? So I think we're still in the early phases of making up the processes that are suitable for machine learning workflows.
Yeah, I think the kind of contemporary version of emailing files for version control is probably putting hyperparameters in file names to track experiments.
Yeah, that's true. Yeah. And actually, let me describe to you another strange process that we use, which is, let's see, talk about version control. So pretty good tools for editing and versioning code. I think we're still, and again, some companies are working on this, but I think still nascent tools for editing and versioning data. And this is one thing I think there is a gap between what is done in academia versus what we need to do to build production machine learning systems. I mean, here's one example. Say we have a test set, train the system, it does poorly on the test set. What do you do? Well, sometimes we go in and edit the test set, right? Because now you can't do that if your goal is to publish a paper. It's not legit to edit the test set. Look, I edited the test set and got great results. You don't want to publish that paper. But from a business production point of view, sometimes you realize the test set labels are wrong. They're not aligned with business objective, and so you go and edit the test set. And I think that needs to become part of our accepted workflow. And then we need better tools for doing the editing and versioning it, and having multiple people collaborate on editing data. I think these are things that I feel like some of my teams, Landing AI, Deep Learning AI Fund, we're making up our own processes, but hopefully as we as a community learn from each other, we can come up with much better ways to do this. One of the challenges I see is that academia has a much easier time working on certain problems where progress is measurable and repeatable. And if every team edits their test set and changes the labels in a different way, it's much harder to benchmark, right? Who's better at editing test set labels? So there's certain category of problems that I think are difficult to study systematically, and so for good or bad reason, they get less attention in academia. Maybe one other example. I was at ICML, International Conference of Machine Learning. There was a lot of discussion on robustness. But maybe what happens is a lot of times is let's say we train a deep learning system to diagnose from X-rays, and we train on high quality, high res X-ray images taken off a Stanford University X-ray machine. Then we published a paper saying this does really well. But if you ship your model to a older hospital down the street with a blurry X-ray machine, where the radiologist has a different protocol for how to orient the patient, it doesn't generalize, right? It doesn't generalize well. So I think we know that this robustness or generalization problem, it is a problem, but how do you systematically study how well your learning algorithm can do on a brand new distribution of data, that the algorithm's never seen, right? So that's just been a relatively more difficult problem to study systematically. So even though this is a problem that we see in production all the time, and we have practical solutions to solving it, I think the amount of attention in academia to this problem is underweighted. And there are some academic papers, but they tend to be framed in like domain adaptation, or framed in certain ways that makes it easier to study systematically. Whereas sometimes the world throws you some random data, and so it's been more difficult to formulate benchmarks to drive forward systematic study of some of these issues.
Along the lines of robustness, when we were chatting a couple of days ago, you mentioned some interesting things that were happening at Landing around managing the risk of machine learning deployments once they get into production. Can you elaborate on that for us?
Yeah, so we've been doing, I feel like my teams do a lot of strange things, and let's talk about some of them. One of the processes I've used before is it's called an FMEA analysis. This is a set of processes that grew up in the hardware world, where if you're building an airplane and you want to make sure the airplane is safe, then you do an analysis on the risks of what could go wrong. And typically you categorize what's the chance of this thing going wrong? What's the chance of this aileron not moving or something? What is the severity? How bad is it if this happens, and how detectable is it, right? So those are the three things you try to categorize each risk. Okay, so one of the things we've been doing is when we look through our machine learning projects, when we think about how to deploy these projects, in a factory or elsewhere, my teams we like going through a very rigorous exercise where we, pre-mortem or think through all the risks and have a team discuss and debate. For each of the things we could go wrong, what's the probability, what's the severity, and what's the detectability, so that we could do a better job seeing around corners and plan for things rather than be surprised by them later. I think we're seeing a lot of startups, there are a lot of machine learning projects that end up at the proof of concept stage, but unable to go beyond. And I think, Landing AI, putting a lot of thought into how to see around corners so that we can take all these things all the way to deployment and production. So I think we've become pretty good at that due to processes like these.
Are there specific examples of issues that the failure mode and effects analysis process has allowed you to avoid?
So maybe just common buckets would be planning for all the ways. I would say the number one most common bucket is planning for the ways that the real-world test sets may be different than the test sets stored on your hard disk. And what are the consequences? What's your mitigation? What's your escalation process? And what's your response time? So you can give reasonable SLAs for what happens to ship a machine learning system, the world does something crazy, and then what?
Is this a process? How broadly applicable do you think this this way of thinking about deploying models and AI products is? Do you think it's something that everybody should be, pulling up the Wikipedia page and figuring out how to do, or is it very specific to the kinds of scenarios you're looking at landing?
Maybe, I think FMEA analysis, and you can look it up on Wikipedia, is a relatively heavyweight process. But maybe for most of my life, most of the projects that I work on, I feel like for most of the projects I work on, I tend to like to identify the risks up front. Actually, when I was at Coursera, one of my direct reports gave me direct feedback, and she said, "Hey, Andrew, I find my one-on-ones with you very depressing because every time we meet, you want to talk about all the things that could go wrong. But look at all the things going right. Why are you always, so depressing?" And I actually told her, "Yes, I understand. Vision for the bright future, but I tend to spend most of my time planning for the scenarios that could go wrong so that we don't hit those." Then she was okay after I gave her that context. But most of my project planning, is the discipline of having a vision for a bright future, but then also being very explicit in listing out all the things that could go wrong so that hopefully we're not, as surprised if something, so we can avoid those outcomes.
Having just planned an event, I can definitely relate to trying to anticipate all the things that could possibly go wrong.
Yeah. And just say, I think, this community, I find the work being done in this community really exciting. I think over the past few years, machine learning research has really raised ahead. Our ability to build machine learning models has really raised ahead. But if this is a set of things, if it's a small set of things needed to do good machine learning model, the set of software you need to write to ship a product is so much bigger than the work of building the machine learning model. So the advances in our ability to build high accuracy machine learning models has raised ahead, and this core technology improvement is driving a lot of value. But there are also a lot of other things that I think our whole community is still figuring out. And I think the ability of organizations like you guys, TWiML, as well as all of us in this community sharing our learnings with each other, I think we have important work to do to move the machine learning world forward. And I think this is especially important if you want machine learning to have an impact outside the software internet industry. I feel like the rise of open source tools, things like TensorFlow, PyTorch, many others, or the rise of archive papers, right? Knowledge you can download for free. That's done a lot to help machine learning break outside the software internet industry, which was going to be a big part of the next wave of where machine learning needs to go.
Awesome. Well, Andrew, thank you so much for joining us and helping me kick off our very first TWIMLcon AI platforms.
Thank you, Sam. Thank you all.